So this weekend I got this totally bizarre, obsessive idea that my couch, the TV, and my armchair all needed to be perfectly equidistant from each other.
Oh no, I know exactly where this is going.
Right. Let me tell you, spending like 30 minutes sweating over a tape measure just to realize I'd completely trapped myself in the corner of the room,
Yeah.
well, it gives you a whole new appreciation for spatial geometry.
I mean, trying to optimize space is surprisingly hard.
It really is, which is exactly why today's deep dive on Intellectually Curious is just so mind-bending. Welcome to the show, everyone. Today, our mission is exploring how an AI, reasoning entirely on its own, just shattered an 80-year-old law of geometry.
And honestly, proving a legendary genius wrong in the process, it's not just a minor technicality either.
Yeah, so lay it out for us. Where does this mystery actually start?
Well, it goes way back to 1946 with a puzzle posed by the mathematician Paul Erdős. It's known as the planar unit distance problem. The premise is, it's deceptively simple.
Okay, simple how?
So, if you place a certain number of points, let's just call that number n on a totally flat plane, what is the absolute maximum number of pairs that can be exactly 1 unit of distance apart?
Okay, so essentially my living room dilemma, but with, a lot more pieces of furniture.
Yes, exactly.
Or I guess it's like trying to perfectly space out guests at a really crowded party so that the maximum number of people are standing exactly 6 feet apart from each other.
That is a perfect analogy. And Erdős conjectured that the most efficient way to maximize those 1 unit distances was basically just a square grid structure.
Okay, grid makes sense.
Right, and he calculated this specific upper limit based on that grid pattern. And here's the crazy part. For nearly 8 decades, the entire math community just assumed he was right.
Wait, I get that Erdős was an absolute genius, but why did everyone just accept this grid guess as the absolute mathematical ceiling for 80 years?
Mostly because human intuition essentially just, hit a wall. The square grid was the most efficient packing method that anyone could mathematically prove or even visualize.
Like, we literally couldn't picture anything better.
Exactly. Without entirely new mathematical tools, we just couldn't imagine a more optimal structure on a flat piece of paper.
Okay, so to break an 80-year assumption, you really need a completely alien perspective. But here's where I kind of have to push back a little bit.
Sure, go for it.
Isn't processing massive amounts of data exactly what AI does? Like, how can a machine have a genuinely creative thought without just brute forcing the math and, calculating a billion grid variations until it finds a loophole?
That is the most fascinating part of all this. It absolutely did not just crunch numbers.
Really?
Really. Top mathematicians reviewed the work and confirmed the AI generated completely original, ingenious ideas. It totally abandoned standard geometric drawing.
Wow, okay, so what did it do instead?
It pulled these incredibly deep concepts from a totally different field, algebraic number theory. Specifically, it used something called Golod-Shafarevich infinite class field towers.
Wait, hold on. Infinite class field towers? You can't just drop a wild phrase like that and move on. How does an algebraic tower help us place dots on a flat piece of paper?
Fair point, fair point. Think of it this way. Instead of trying to physically map out dots on a grid, the AI translated the geometric rules of distance into pure algebraic equations.
Okay, turning geometry into algebra.
Right. And in abstract algebra, a class field tower is a way of basically infinitely stacking complex numerical relationships without them collapsing into contradictions.
Oh.
So by turning the geometry problem into an algebra problem, the AI constructed a sequence of numbers that mathematically packed way more valid one-unit relationships together than a physical grid ever could.
So instead of trying millions of grid combinations by brute force, it's like the AI stepped out of the 2D plane entirely, looked at the geometry puzzle through the lens of abstract algebra, and just found a hidden shortcut we couldn't visualize.
Precisely. It creatively built a bridge between two totally distinct branches of math that humans just hadn't thought to connect for this specific problem.
Which completely shifts how we view artificial intelligence. Speaking of applying AI to solve really tough real-world problems, that is exactly what our sponsor, Embersilk, does.
Oh, absolutely.
If you need help with AI training or automation integration or custom software development, they are the experts. They are amazing at uncovering where AI agents can actually make the most impact for your business or even your personal life.
Yeah, they really understand how to leverage these new tools.
Exactly. You can check them out at embersilk.com for all your AI needs. But getting back to what you were saying, if an AI can creatively connect distant mathematical concepts like this, its potential for human progress is just truly staggering.
It really is. The scientific community is incredibly optimistic right now. I mean, top mathematicians are saying this proves AI is no longer just a fancy calculator.
Right, it's becoming a true research partner.
Yes. We are looking at a really bright future where humans and AI team up to solve our hardest challenges in things like biology, materials science, medicine, you name it.
I read that one of the mathematicians who reviewed this proof said AI is helping us more fully explore the cathedral of mathematics. I just think that's such a beautiful way to frame it.
It truly is. Because it's not about machines replacing human insight. It's about, expanding our capacity to see the actual architecture of the universe.
Exactly. And it leaves you with something pretty wild to think about.
Yeah.
We spent 80 years thinking we knew the absolute limits of 2D space.
Yeah, a long time to be stuck on a grid.
Right. So if an AI can find hidden dimensions and shortcuts in a flat piece of paper, what other unbreakable laws of physics or biology are just waiting for a new perspective to solve them? Think about that for a bit.
It is a very exciting time.
It really is. Well, if you enjoyed this deep dive, please subscribe to the show. And hey, leave us a 5-star review if you can. It really does help get the word out.
Absolutely.
Thanks for tuning in, and we will catch you next time.